In that case, let's try some more examples then. All right, last one on the page. So again, that's our child function. So in this case, our parent function is going to be, remember, be careful, this is a cube, so it's going to be the third root of x is our parent function. So same process. This one can be negative because if you see the graph of this one, it goes to the side. So we know that can be it. So it can go that way. -1, 0, and 1, just to make it easier for ourselves. So plug in -1, and you could use a calculator if you want. The through to -1 is just, or you could just believe me, is just going to be -1. Third root of 0, still 0. It's a boring number, right? And the third root of 1 is also just 1. That's the reason why those are nice numbers to deal with when it comes to it. Okay. And same thing, we find out h, k, and the a term. And again, a is going to be 1, h is going to be -1, and k is going to be -2 this time. Right, so we do this transformation. It's going to be x now -1 and y -2 instead of adding them. Right, and just do the same thing. So all the x's, we're going to subtract 1 this time. So -1 -1 gives you -2. 0 -1 is -1. And then 1 -1 gives you 0. Okay, and I would do the same thing for the y's, but in this case, we're going to subtract 2, right? So let's see, -1 -2 is -3. 0 -2 is -2. And then last one, 1 -2 gives you -1. Okay. And again, we graph it and we're done with this question altogether. So -2, -3. -1, -2. And then 0, -1. Now, remember, I'm not making a straight line, right? So that's the reason why you're going to have to know what these graphs should look like. And it's the third root of x, so it should look like this. So it's going to curve at those points. So I got to do the same thing. So it should curve at these points. So just be careful, right? You still have to understand how the function or how the graphs look at the ends, at the tails, right? You can't just make a straight line because it's not a straight line in this case. So just be very careful, because we're sketching it, when it comes to it. Right. Any questions on these two at all? Everybody comfortable? Okay. All right, good. Okay, so a couple more examples. All right. So parent function here, we're going to talk about, right, squared, so it's just going to be x squared. Okay. So let's try -1, 0, and 1. Again, right, you don't have to do 2 off the bat. You could like, any numbers, but you don't want to go too crazy on the graph. So -1 squared gives you +1, 0 squared is 0, and then 1 squared is just 1. Right? Okay, and then find your A, H, and K. So A, again, is 1, H is +3, and K is -3, right? So everybody good there? Find your H and K's. Okay, all good. All right. And now it's going to be X plus the H, and now Y minus the K, so -3. All right, so now -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. Next up, Y's. 1 minus 3 is -2. 0 minus 3 is -3. And then 1 minus 3 is again -2. And now graph it and we're done. So 2 minus 2, 3 minus 3, and then 4 minus 2. And I know this is a parabola, so it looks like a U. And there we go. Questions there? Nope, comfortable? Okay. So let's do, we're going to do 2 more examples. So one right after this one. I want to give you guys a scenario of the other one. So for this case, our parent function is one we did earlier. It's the absolute value of x. Okay. Okay. So we did this earlier, so I'm just going to write down the numbers we did earlier. So I'll just do -1, 0, and 1. And those were, again, those same answers. Now, what I want you guys to do for your extra credit opportunity is find the 3 numbers we have here. So what is your A, H, and K? Go for it. Just put it in the chat. Okay. Give you another quick 30 seconds for the people who haven't finished. All right, everybody had a chance. Put it in. Close it in a couple of seconds. Okay, good. It looks like everybody got it. Looks like I tricked 1 or 2 people. So here, -1 is on the outside. H is -1 as well. So be careful, right? Opposite side. I think that's where I got 1 or 2 people. And your K is also -4. Right? Okay. Now we have an A value that's not 1. So what's going to happen here?
So I'm sorry, real quick. So we wouldn't use that negative sign outside of the absolute. Oh, right, it's absolute. Never mind.
Oh yeah, we did. That's the so that's the A value. So
No,
that's the,
I was saying like the negative to multiply against the positive one, which would equal a negative one, which would result in a positive one.
oh, no, you don't want to put it in. No, be
Okay.
careful, yeah. So you leave it on the outside. That's why, yeah, be careful.
Thank you.
Yeah, so it's a specific way of doing it. So usually that's why you always want to find the 3 numbers given to you. And that's going to change everything, yeah. So you're kind of right. It is going to tweak it, but in a little different way. Okay. So we have a number on the outside. So we need to figure out, is it a vertical or a horizontal stretch, right? Because that changes everything. So if we go back over here, it says if the numbers on the outside, it's going to affect the y coordinates, right? So if the numbers on the outside, it's going to affect the y coordinates by multiplying by that number. Okay. So let's go back over here. In this case, the A value is on the outside, so it's going to affect the y values. How this is going to come into play now, so again, x is not affected, so we know it's going to be x minus 1, because that's the h value. That's okay. But now I have to multiply the y values by -1, then subtract by 4. Because again, this a value now it's being affected because we multiply. And this thing now can't focus. If I do this, focus on the pen. Okay, there we go. So as we multiply by the a value, in this case by -1. Okay. All right, but we're gonna do the same thing. The only difference is it's got a little bit more work because now we have to multiply. But again, still the exact same template. Okay. So let's do the easy one first, the x's, because that's the same ones we've done so far, right? Nothing too different there. So first, -1 minus 1 is -2. 0 minus 1 is -1. And then 1 minus 1, that's going to give you 0. Okay. All right. So now how is the new one going to come into play? All right. I have enough space here. So for these, I'm going to plug in and see what we get out. So it's going to be -1 times 1 minus 4, right? So order operations. First, we're going to multiply. So -1 times 1, -1, minus 4, -5. There we go. Questions so far on that? So everybody comfortable doing the first one? All right. Keep going. Now we plug in 0. So -1 times 0 minus 4. That gives me 0. Minus 4 is just -4. And the last one, -1 times 1 again, another -4. So it gives you -1 minus 4, back to -5. So again, good. Okay, graph it, and we're done. Again, the only difference between the last ones is we actually have a number now on the outside. Okay. So graphing these up gives you -2, -5, -1, -4, and then 0, -5. Now remember, this is an absolute value, so I know it's going to look like a V, but it's a V looking down this time. And there is our graph. So questions when we have the A on the outside. The A on the inside is a little bit more difficult. Is everybody good? Okay. So now what happens if you have the scenario of A's on the inside? And how is that going to look? Okay. So before we finish this up, let's just do one quick example. Do it, go over in math. So let's do this one. So we want to graph the absolute value of 2x minus 3 plus 1. Again, I don't want to distribute it because that number is very special to us, right, when it comes to it. All right, so we know the parent function is just going to be absolute value of x, right? We've done this one before. Same thing, do a t-chart. And this time I'll put -2, 0, and 2. And you'll see why I do that. It's just for me to understand knowing the problem. Because I know you guys will hate fractions. So just, again, you can pick any ones you want, right? I just decided to choose these two or these three here. Okay. All right, and then remember, we plug it into our parent function. So that's going to be +2, 0, and then +2, right? And just looking at here. Okay. All right, now let's write down our three values. So now this time A is going to be +2, H is going to be +3, and K is also going to be positive, right? The +1. So again, going any further, any questions on finding the three numbers we're looking for? Okay.
So the reason why A is not going to be 1 is simply because the 2 is outside of a parenthesis?
Yeah, we actually have a 2 inside the value, right? We have a 2 inside the absolute value.
Would it matter, or would there ever be a problem where there would still be another value outside of the absolute value and inside?
Yes, but you won't have something like that in this class.
Oh, cool.
It's going to be one or the other to help you out, yeah. So like you could have a 4 out here. It just makes things more complicated, but you know, since we're learning, one or the other is good enough so you guys can do it, right? Yeah. So like, I don't even think your homework has a couple questions like that. It's just going to be one or the other to help you guys out. Yeah, since you're just learning when it comes to it. Yeah. Good question though. Good question. So A is now on the inside, right? So if we go back to our rules, if A is in the inside, like this, it affects the x coordinates by the exact same matter. We're going to be multiplying. However, we're going to be multiplying by 1 over the number we actually have. So in other words, since A is 2, we're going to be multiplying by 1/2, 1 over 2 to the x's. So it's going to look like this now. So if we do this transformation, be 1/2 times x, and then plus 3, because remember, we still have the h there. And the y's are not being affected by that a, and so it's just going to be +1 there. So you guys see the difference now between these two. These two here, right? Number on the outside affects the y's. Number on the inside affects the x's by going 1 over that individual number. So never both. So this A is going to be one or the other. This only affect one or the other here. And now that we have everything written down, now use this transformation to find the new x and y values we're looking for. So x's, so again, we're just going to plug in chug, right? So 1/2 times -2 plus 3, and just to simplify. So this is -2/2 plus 3. So this just becomes -1. So that gives you +2. Plug in 0. 1/2 times 0 plus 3. That's just 0. So we just get 3. Last one. 1/2 times 2 plus 3. This is 2/2, which ends up being 1 plus 3, which gives you 4. And there we go. So we're finished with the x's. So again, before we go any further, any questions there so far? And then the y's are much simpler, right? Because now it's just going to be adding 1 to all of these. So 2 plus 1 is 3. 0 plus 1 is 1. 2 plus 1 is 3. And there we go. And then finally, we just graph it. If you're wondering, if you take pre-cal, that's when they give you the crazy stuff. They put like all these numbers everywhere. If you guys are wondering, that kind of stuff. So 2 up 3, +3, 1, +4, 3. And it's an absolute value, so it's going to look like a V. And there you go. Okay, so any questions when you have a number inside? Everybody comfortable? Okay, good. All right. So that's pretty much the big bulk of this chapter or this section. Last little snippet is very simple. It's defining if it's a function is even or odd, and it's actually not that bad. A function is even if we plug in -x and we literally get the exact same thing out. So in other words, nothing changes. A function is odd if I plug in -x and I get the negative of what I started with out. That makes it an odd function. Okay. Now, this is kind of an obscure definition. So it's probably easier if I just show you an example of what happens, what does it mean by even and odd, and we'll go on from there. Okay. So to figure out if you have an even odd, we're going to plug in -x into here. So how that's going to go is you're going to plug in -x everywhere you see an x and just simplify. So -x squared gives you now +x squared minus 8, right? Okay, and then we're going to check. So I plug it in. It's even if I get literally the exact same thing out. Do I get the exact same thing out? That's a big fat what?
Yes.
Yes, perfect. So therefore, it's an even function. It's that simple. Okay. So how do you know if it's an odd function? Well, let's go to B. So same thing, we're going to plug in -x everywhere I see an x. So it's going to look like this, like that. Okay. All right, this is a little trick question, right? So the triple negative ends up being a -x to the third, and this ends up being +x, right? Negative cancel out to make you positive. Okay, well, it's not even because it's not exactly the exact same thing out, right? So it's not even. so cross even. So let's check if it's odd. So to check if it's odd, what you want to do is factor out a -1. Okay, so in other words, if you factor out, there's just the signs change, right? So instead of negative has now become a positive, and because of a positive now becomes a negative. Okay. Now, it's odd if I have a negative and literally the exact same thing I had before. So is that the case? So I had this before, I have this still inside, but it's just a negative on the outside. So therefore, this is called an odd function. Because you have a negative on the outside, and in parentheses, you literally have the exact same thing what we started with. That's what's called an odd function. Okay. And in most cases, to figure out if you have an odd, you always have to factor out -1 to see, do you get the original one back inside the parentheses. Questions there at all? No? Pretty good? Okay, let's do C. So -x to the 4th plus 5. So this is 4 negatives, that makes it positive. So therefore, what is this, even or odd? Even. Look at that. Definitely want this in the test, right? The whole test looks like this. Not much work. All right, let's do the last one. So very similar way on the top right. So triple negative, that means it's going to be a negative, right? Okay, so look is kind of odd, right? Because they have a very similar situation. So let's take out a -1. So let's just factor it out. All that does is change the sign. So we have a positive x to the 3rd and a positive 1. Well, you may say, oh, it's odd. However, you got to be careful. This says x to the 3rd minus 1, and this is x to the 3rd plus 1. So they're not exactly the same. So what is this? That's a trick question. It's neither. It's neither even or odd. Trick question. So you could have even, odd, or neither, neither, whatever you prefer. Okay. So those are the 3 situations you can have when it comes to asking if it's even or odd. So even, odd, or neither or neither. So before we finish this section, have any of you guys heard of the word proof before in mathematics? Guessing that's a no? Okay, so if you haven't, it's just a fancy for saying show something actually works mathematically. And that's one word a lot of students get scared of, like, oh man, a proof, what? Because there's more writing than actual mathematics behind it. But believe it or not, this right here is actually a proof, or is defined to be a proof. Because you're just showing algebraically if it's even or odd, respectively, right? And just following the steps. So if you guys go into higher math and say, oh, I got to prove something, well, you already did it back in college algebra.